What's going on? Welcome back and happy Friday. Today we're going to go over Splunk 3. So specifically pivoting back to endpoint events or task 6. So in this task, we're going to have around 8 questions. The questions revolve around investigating malware infection through Microsoft embedded documents or Microsoft or macro embedded documents. So we will be investigating the malware, how the malware infected the endpoints, and we will look at the persistence actions taken by the attackers when they created users inside the system and they elevated their privileges. So this task is pretty much useful and it is a great learning experience. So let's start with question 1. The question 1 is saying, what is the full user agent string that uploaded the malicious link to OneDrive? So there was an attacker who uploaded a malicious link to Microsoft Office OneDrive. And through that malicious link, they crafted the first infection. So if you go to question 1 guidance, we read through that. We are tasked, or you are tasked, to find the user agent that uploaded a malicious link to OneDrive. So you already know you have a source of antivirus. Maybe this is a good place to start. Another starting point is Office 365. You might want to start there instead. So in the question, you see here, it is mentioning about OneDrive. So it's talking about OneDrive. So what's as a source type, we can use Microsoft Office 365, or we can use semantic antivirus as a source type, because as you can see here, we have a malicious link, so it might have been caught by semantic, and also it might have generated an event for that. So source type as semantic antivirus is also an option to look at. So you know a file was uploaded, and you know its file extension. All you have, let me close this, I hate that. Okay, you have all you need. All right, so let's jump to Splunk and see how we can find this malicious link. First, let's modify the IP address or update the IP address. And let's see here. Okay, so we are here. Fine. Let me take this first for speed. Okay, I'm gonna paste the query and delete this part. Or let me search with that query. So the first thing, as you can see, we selected source type as Microsoft Office 365, since we're talking about OneDrive. Now, how I came up with all of these fields. Let me cancel these fields and see how the results are displayed. So we got around 51 events, or more, 1073 events. Now, if you go down, look at the interesting fields like we always do to explore more how we can find the useful ones. So basically, there is one called workload. The workload specifies the type of software. So in my case, it is OneDrive. So here you go, we got one workload equal OneDrive. We got around 829 events. And here you have the actions. Let's see here, event source, SharePoint, event type, nope. So you have 13 user agents, but we can't know for sure which one is the answer. So we have to filter them more. File name, file path, index. All of these are not important. Source type, here are the sources as well. So if we are back, nope, this is the next task. A malicious file link uploaded to OneDrive. So there might be a field about the operation, which is upload here. So we click on file uploaded as an operation, and here we got around 7 events. That's how I came up with the full query here, as you can see. Now I use table just for sorting the results and displaying the events. I use time to display them in ascending order, and I use source IP. So I want to take a look and determine what is the IP address that has performed the operation. Username, the object, the thing that has been uploaded or the file, and the user agent, which is the thing we're looking for. Click on search. Now we're looking for a file that has link as an extension, which is this file, and the user agent is this one. So here you have the first answer. Next one. What was the name of the macro-enabled attachment? Macro-enabled attachment identified as malware. So here's attachment word mentioned in the question. So it means we have to look at SMTP as, or stream SMTP as a source type. Enter. Now, what was the name of the macro-enabled attachment identified as malware? So it's already saying that the malware or the attachment is malware and it has been identified and detected. So in Microsoft, when a macro-enabled document is detected and considered as a malware, okay, embedded with malware, Microsoft will change the file name for something called malware text alert. So we look for the word alert based on that information. And then here we got new fields appearing on the left. We have attached file name. We have one called malware alert text. So this is the file name, okay, that Microsoft assigns to the attachment when it detects it as a malware. So we click on that. And then we got only one event. So let's take a look at the raw data. All right, scroll down. So let's read through the content of the email. All right, so here we start. Content transfer encoding. And here is a financial model we can use for FY 2019 planning. For the worksheet to operate properly, you will need to enable macros. So this is form of social engineering used in order to convince the victim to open the attachment. Thanks, Bruce. And here what seems to be the, as you can see, malware alert. And after that, you got base64 string. So you start from here. Take this base64, encode it. Base64 decode. So let's go to this site and decode that string. Malware was detected in one or more attachments included. So this is the file name, Frothley Brewery Financial Planning, FY 2019, and because it's a draft, just continue with the work with draft and answer with the question. Of course, the extension is XLSM. You have to know this by yourself because any macro-enabled document or Microsoft document has an extension of XLSM. What is the name of the executable that was embedded in the malware? Answer guidance include the file extension. So here we're given, or we know beforehand, that the attacker has sent an Excel document that contains an embedded macro job. Okay. Now the macro job invokes some executable file. So the executable file was embedded in the document. We have to find out what was that executable file. So here we're looking forward to use sysmon as a source type because sysmonitor all events that have to do with executable file that has been executed or detected as malware. We have to look in the sysmonitor. So let me grab the command from here. Yeah, okay, it is one event log. So this is the full command. Let's dissect the command and answer one by one. So first we have the win event log application. We use win event log application because we're looking to find out the application that has been executed. All logs about applications and their execution are found in the win event log / application. So you click on search, and we know that the malware or the executable file was identified as malware. So let's see if there is a field here, signature ID, source name. So let's look at the source names. We have semantic antivirus. So it's only semantic antivirus that is able to label that as malware. So we use that in the query. We have source name semantic antivirus. We got around 18 events. So now, and also we know that the embedded executable file was, inside the Excel document that starts with Frothley. So if we use Frothley in the search, you can narrow this down more. So you have one event. If you look at the description, security risk found, file, this is the macro-enabled file, and yep. So what is required here? It is the name of the executable. So still here, we are not able to extract the file name that was embedded in the document. We're only able to find out the event that triggered, able to find out the event actually, the event that triggered this. So basically, now we know where to look. So what we can do here, we can modify this and use sysmonitor as a source. So we take this one. So sysmonitor operational contains information about the CMD line or the CMD used by the malware. So since the macro-enabled document contains an executable file, this executable file, when it was executed, it performed some command, right? So in order to know what was the command and what was the executable name that performed the command, we have to look in the Microsoft Windows sysmonitor operational events. And we put XLSM because we're looking for the executable file that was embedded in a document which has the extension of XLSM. Click on search and you will get around how many events? Let's see. 2 events. So let's sort them. Reverse. Let's look at the first one. So the image field contains the name of the executable file that was executed. Both cases it is hxtcr.exe, which is the answer. What is the password for the user that was successfully created by the user root on the on-premises Linux system? So there was a user, okay, that has been created by the root user. Notice that it is not the root user which has been created, of course. There was a user on the system that was created by the root. We have to find out the password for that user. So you know beforehand, guys, that in Linux, the command used to add a user is user add or add user. So we can sort for that, add user or user add. So we got around 2,896 events. Let's go back and let's type here root. Or before typing root, let's go back. This won't change anything. Let's take a look at the source types that contained these 2 commands. We have source. So in sources, we have var log auth.log, which is the log contained all of the events about the authentication and user operations and authentication. So we click on that and we got 1. Let's take a look. So here we have a new user added. The name of the user is Tomcat7. and it was added by, as you can see, the root user. So this is what we're looking for, but it doesn't contain the password, right? So we have to find out the password. So what we can do here, we can go back, cancel all of that, and type tomcat7 16 events, source types. Great, we have OS query. Let's take a look at the OS query results, because most of the time OS query logs all of these events. So we have two. Let's take a look at this one. So indeed, as you can see, user/sbin/user_add. As you can see here, the CMD line. CMD line user add -ou tomcat7 I love David Vervi. So this is the password. What is the name of the user that was created after the endpoint was compromised? So here we're talking about persistence. An endpoint has been compromised. We have to find out what is the user that has been created after the compromise. You can also take a look at the hints. So for this question, the hint here is to use when event log security. In Windows, the logs that contain the user operations are found in when event log security. In Linux, it is var in the authentication log. So here, let's take a look, or let's filter. Let me take the commands, save time. Okay, this one. So why do we have event 4720? Because this is the event code for user add in Windows. Click on search, you will immediately jump to the answer. Yeah. The question is, what is the name of the user? So if you scroll down, you see the operation, which is user add, and the name of the user is svcvnc. Next one, based on the previous question, what groups was this user assigned to after the endpoint was compromised? This is also a persistence step. Once a user has been created by the attacker, they will try to add the user to other groups, especially the administrator group. So we can keep the source type as is, and we can search for groups or group. Oh, search for SV, the user itself, svc vnc. 11. So here, as you can see, let's take a look at this one. A member was added to a security-enabled local group. So this is an event, an example event we want to look at, but let's filter the events more. So event type, or let's filter by the event code 4732 for user add or group add, and also use the same user account. You have two. So the first group was users, and the next group was administrators. Right, what is the process ID of the process listening on lead port? Now lead port is, let's Google it, is 1337. So if you use 1337 in the search here, only 1337, yeah. Yeah, I guess I forgot the one. What is the process ID? So let's take a look at the source types. Sources. Okay, open ports. So here we got PID of the processes. But first we have to filter for a specific resource, a specific source type. So DNS, ICMP, MySQL. Here we got the destinations. process. Okay. Hint, OS query is logging open ports. So if you use OS query here as a source type, let's see if I have got this command. Oh yeah, I've got it here. Okay. Let's use OS query results. We have 5 events. If I take a look at the interesting fields, we have column.ports, which is 1337. Click on that. And you'll end up with one event, which contains the process ID. Let's take a look at the event. PID is 14356. So also OS query can be used to look at the processes BITs and the open ports. What is the MD5 value of the file downloaded to Fyodor's endpoint system and used to scan Frothley's network? So there was a file downloaded to Fyodor's computer, and this file was executed and launched to scan Frothley's network. If you look at the hint, it's suggesting to use sysmon because sysmonitor provides hash values when processes are executed. Figure out what event code you need to look at for that. So here we have the host, which is Fyodor, and we have to use sysmonitor. Host, select Fyodor, source types, select sysmonitor. Yeah, let me type it myself. So we got around 4,126 events. So we're looking for MD5 hash. Okay, if we use MD5, let's try 165 events. If you look at the event code, you have, well, let's search back with the old query. So when a process is executed, the event code for that is 1. So filter for 1 as an event code. And here we have 31 events, 158 events. Still, we've got some more to do. So here are the applications that have been launched. Also have the CMD line. So what we can do here, we can, let's use table or stats count by app, or forget the stats. Let's use table to display the apps, and also reverse to see which app has been executed first. What is the MD5 hash of the file? Let's take a look. All of these files are system32, so we keep them at last. Let's see first suspicious directories. System32, program files, Outlook, temp. We have temp directory here. This one is kinda suspicious since the file is the name is misspelled for Internet Explorer, and also we have next. Only these. Temp. I guess there was 1 before temp, before this one. Also, you have dim host, IE Explorer, yeah, so I overlooked this. As you can see, we have one. The first one was hdoor.exe. The question here was the MD5 file of the file downloaded to Theodore endpoint and used to scan frothy network. Let's take this. Where was this? Okay. Filter, say that app equal okay. How about we use only the name of the app? Take a look at the CMD line or the command line. This is the command. And this command seems like it is scanning a network, as you can see. Take a look at this. Let's see if there's MD5 hashes. So this is the MD5 hash. Take it and answer with it. So that was these were the answers for this task. I know it was good. It was not easy actually to find the answers. You may see that finding the answers is a bit easy because I have prepared this before, but finding the answers for this task was not easy at all, especially this one. And let me check. And the last one. So the second one and the last one were the hardest for me. I hope you enjoyed the video and see you later.